Hello, future users, subscribers, viewers, and students. There is another video in structural analysis. This may also fall in mechanics of materials, but this is a challenging one. This is about beam deflections, and I'll solve this in as many ways as I can. This is the first part. The solution is by double integration. The beam is subjected to the load shown. If EI is constant, determine the slopes and deflection at points A, B, C, D, and E. So by double integration method, in this method, I set up two differential equations for the elastic curve. Now, you may have one equation if you want to extend that, but I'll just present two uh, differential equations so that whenever you encounter a segment where the loading is complicated, quite complicated, and you can hardly extend it or you can hardly express the moment for the entire beam as a function of one distance x from the leftmost end, then this is the idea. So in this presentation, I have two segments. This is the first one from A to C, and the second one from C to E. Now, the reactions, because this is structural analysis, so I leave it to you to compute for the reactions. So these are the reactions at A, 107 over 3 kilonewtons, and at D, 353 over 6 kilonewtons. Of course, if you cannot solve this, then you cannot be successful in structural analysis. You better go back to statics if computing the reactions will still be your problem. So for the first differential equation, EI y double prime AC, so the moment at this section is equal to 107 over 3 times x, then plus this area, which is 1/2 of x minus 3, x minus 3 times w, and w is equal to 5 times x minus 3 from here. So we have w, that's also w. I make the trapezoidal loading rectangular loading, so I also fill that up by this triangular loading up to balance or to counter. So W as to x minus 3, this is x minus 3, equals 15 kilonewtons per meter, where 15 is 30 kilonewtons per meter minus 15 kilonewtons per meter as to 3 meters. So that's 3 meters, which is this. So that's why W is 5 times x minus 3, which is this. Then the moment arm is x minus 3 divided by 3. Then minus the moment of this uniform load, which is 30 times quantity x minus 3, and the moment arm x minus 3 over 2. So 30 over 2 is 15. So minus 15 x minus 3 square. Simplifying, so we have EI y double prime is 107 over 3x plus 5 over 6 quantity x minus 3 cubed minus 15 times x minus 3 square. Integrating, so the integral of this term is 107 over 6x square. Then the integral of the second, 5 over 6 times 4, so 5 over 24, x minus 3 quantity to the fourth. Then 15 over 3 is 5, so minus 5 quantity x minus 3 cubed plus c sub 1. Integrating again, so we have 107 over 18 x cubed plus 1 over 25 times 5, cancel 5, so 1 over 24 x minus 3 to the fifth, then minus 5 over 4 quantity x minus 3 to the fourth plus c sub 1x. There is no c sub 2. There's no deflection at A. But there is a slope at A. That's why we have c sub 1. So c sub 1 divided by EI is the slope at A. That's the interpretation. So for the second segment, CE, so the right side is simpler. So this is the direction of positive shear. For the right section downward, then left section upward. For moment, that's the positive sense of moment, counterclockwise for the right section, clockwise for the left section. So considering CDE, summation forces y equals 0, so we have shear at C, assume positive, plus 353 over 6 equals 15. So shear at C is negative 263 over 6 kilonewtons. Likewise, summation moment about C equals 0, clockwise positive, so m sub C plus 15 times 5 equals 353 over 6 times 3. So m sub C is positive 101.5 kilonewton meter. Therefore, we can now set up the differential equation for this second segment. EI y double prime CE is equal to shear negative 263 over 6 times x1, then plus moment, which is positive 101.5 plus 353 over 6 times quantity x1 minus 3. Integrating, you have negative 263 over 12 x1 squared plus 101.5 x sub 1 plus 353 over 12 quantity x1 minus 3 squared, then plus c sub 3. So c sub 3 when x1 is 0 is the slope at C. Then there is also deflection at C, so it is represented by C sub 4. Integrating again, we have negative 263 over 36 x1 cubed plus 101.5 over 2, so that's 50.75 x1 square plus 353 over 12 times 3, so 36 x1 minus 3 cubed plus c sub 3x plus c sub 4. C sub 4 is the c sub 4 divided by EI is the deflection at C, while c sub 3 divided by EI is the slope at C. So we have c sub 3 x1 plus c sub 4. So when x1 is equal to 3 meters here, x1 is 3 meters at D, y sub C is 0 or the deflection is 0. So substitute into this formula, negative 263 over 36 3 cubed plus 50.75 3 square, that is 0, plus c sub 3 times 3 plus c sub 4 equals 0. Simplifying, we have 3c sub 3 plus c sub 4 equals negative 259.5. Call that equation A. Then at C, we have EIY AC for portion AC equal to the deflection also for portion CE. So for AC, we substitute x is 6, while for CE, because x1 is 0, it is just equal to c sub 4 at the right side. So for AC, 107 over 18 times 6 cubed plus 6 minus 3, so 3 to the 5th over 24, then minus 5 times 3 to the 4th over 4, then plus c sub 1 times 6. Then at the right side, it is just c sub 4 because x1 is 0. So simplifying, we have 6 c sub 1 minus c sub 4 equals negative 1192.875. Call that equation B. Then finally, the slope at C is the same for both sides of the beam or for both differential equations at C. So EI y prime AC equals EI y prime CE. So for CE, it is just C sub 3 here. X1 is 0. Then for AC, substitute x is 6. So 107 times 6 squared over 6 plus 5 over 24 times 3 to the fourth minus 5 times 3 cubed plus c sub 1 equals c sub 3. Simplifying, c sub 1 minus c sub 3 equals negative 523.875. Call that equation C. We can now solve equations A, B, and C simultaneously with your high-tech calculator. So we obtain c sub 1 equals negative 336, c sub 3 187.875, C sub 4 negative 823.125. So as mentioned earlier, C sub 1 divided by EI is theta A. So negative 336 over EI, that's theta A. Then C sub 3 is theta C. So divided by EI, so 187.875 over EI, that's theta C. And C sub 4 divided by EI is delta C. So delta C is negative 823.125 over EI. We can now compute slope at B by setting x is 3 in this equation here. Use your calculator, 107 over 6 times 3 squared. So this is 0, that is 0, plus C sub 1, and C sub 1 is negative 336. So you can now compute theta B. It is equal to negative 175.5 over EI. Then delta B, x is 3 also into this equation, 107 times 3 cubed over 18 plus 0 minus 0 plus C1 negative 336 times 3. And you'll get delta B equals negative 847.5 over EI. Then for theta D, we set x1 equals 3 into this equation here. So negative 263 over 12, 3 squared plus 101.5 times 3, then 0, then plus C sub 3, which is equal to 187.875. And you will get theta A equals theta D equals 295.125 over EI. Then for theta E, set x1 equals 5 into the same formula here, negative 263 times 5 squared over 12 plus 101.5 times 5, then plus 353 times 2 squared over 12 plus C sub 3, which is 187.875. You will get theta E equals 265.125 over EI. And finally, for delta E, set x1 equals 5 and substitute into this formula here. So negative 263 times 5 cubed over 36 plus 50.75 times 5 squared plus 353